Hello. The project of our group is variational sequence labeling with external knowledge. My name is Yifei Li, and my teammates are Chi Wu and Wenhuan Sun. Okay, first, let me introduce the sequence labeling question. The task is described as following. The input is a sequence of words, we can call it a sentence, and the output is a sequence of labels, one label for each word. For example, here is the sentence. Nado monitors Muslim move towards Ten's village. And in this sentence, Nado and Muslim are both entities. So we will give them special labels like BORG or BMISC. However, the other words like monitor or move, they are verbs and they are not entity at all, so we will just give them label as others. And there are two major types of sequence labeling. The first one is named entity recognition or NER, and the other one is part of speech or POS. Traditional solutions for sequence labeling is fully supervised learning. However, these methods suffer from limited label data problem. And so recently, there are some modern methods. For example, variational regularization and external knowledge bases. We will explore these two modern methods in our proposed methods. And next, I want to briefly introduce some related work about the traditional solutions. The conceptual model of sequence labeling is we are given a sequence of observed words and we want to inference the latent labels. And the traditional methods some researchers use is linear statistical models like HMM and CRF. However, recently, neural networks are commonly used. For example, RNN and LSTM are also introduced to this task. And recently, there are some combination of the both methods. For example, there is a proposal that we can combine bidirectional LSTM and CRF together. And this one is used for our baseline model. The baseline model is shown as the figure. The feature map is extracted from both word level features and character level features. The word level features are word embeddings, and the character level features are extracted by CNN or RNN. And then these features are fed into a bidirectional LSTM. And the output of this LSTM is then fed to the CRF as output layer. And CRF will give us the prediction of the sequence labeling. And next, my teammates will introduce our own proposal and method.
Our projects plan to obtain the great performance on label data first, and then explore how to learn a reasonable model with limited labels. One related work about this is using variational regularization to improve the label efficiency. At first, it's a natural way to incorporate unlabeled data to provide the guidance for the model training. Also, it allows us to disentangle latent variables and use neuron variational methods. This is our model. We use two separate latent variables and combine the latent hierarchy structures with traditional CIF model. Since CIF is globally conditional on the full sentence and can help deal with the independence problem. Specifically, we use one latent variable to predict self given the surrounding context. This is a regularization term, and we can make use of unlabeled data here. The other latent variable is used to be fed into the CIF layer, and it will be used to predict the label. Here, we also apply the hierarchy structure where the latent variable y is used to obtain the latent variable z. Besides the regularization method, we try to incorporate external knowledge base to improve the model performance. Specifically, we use the external knowledge graph to provide pseudo-labels for unlabeled data, and use both labeled data and unlabeled data with pseudo-labels to train the model. One problem is that we are not able to find all tokens in the external knowledge base, so we have the incomplete data annotations for the unlabeled data. Therefore, we need to learn from partial labeled data. For example, here we only have the annotation for the person, and the one way to deal with is to fill the tokens without pseudo labels with O, which means outside any entity in the NER task. Another way is to enumerate all possible labels for tokens without pseudo labels. Specifically, let S represent the set of all possible complete label sequence. Then the loss function can be written as this. Q represents the weight of possible label, and C is the classifier.
In order to incorporate external knowledge base into model learning, we need to be able to extract external knowledge from the structured open source knowledge base, for which we've chosen Wikidata, which has around 85 million annotated items with their properties. For example, all the items, for example, the London and Berlin items, they are listed with their properties, references, qualifiers, so that all the individual items or tokens in this data set are kind of interconnected. Through this kind of connectivity, we were able to have or to observe the possible correlations between properties and their part of speech tags. However, the Wikidata set is pretty big. It was more than 500 gigabytes, which requires a lot of computational power to process. So as an alternative, we turn to these Kensho-derived Wikimedia datasets, the KDW datasets. So basically, it was a extracted Wikidata graph with around 500 million tokens. And for example, here's a process of how we can observe or obtain the statements-based queries from this data set. For example, we're interested in this item, Grace Hopper, and then we first obtain the item ID, and then we just search through the data set so that we can find the statements. For example, we have the date of birth, the instance of education of this person, and then we can go ahead and find the possible correlations between those properties. For example, we can find the exact date of birth for this person. So with that in mind, we will need to be able to obtain a set of rules to assign those part of speech tags to unlabeled tokens for data augmentation. To do this, we will want to map the part of speech tags to those newly found property to data value tuples. For example, we have this token, Grace Hopper, and then the label data would tell us the pause tags, and the KDW data tell us all the properties of this person and their data values. So we have those value mappings between them. And then, of course, some simplification during the mappings are sometimes the property alone is sufficient. For example, in this case, Donald Trump is a person, and it also has a property of being the spouse of Melania Trump, which is, so the property itself, the spouse itself is more than enough for that. So we don't have to query about the Melania Trump as the target value. So during the tagging, some punctuations, general types of verbs, and other pronouns that begin with lower cases were neglected. So just in summary, we have a lot of sparsity in pseudocode assignment in this the cancel database-based rules. To do that, there's still a large amount of tokens that still needs assignments after this procedure. So the partial supervised learning are needed.
This is our data set, and we will use IOB labeling scheme. We will use 10% data as our label data. As for the external knowledge base, we will use Wikidata. And this is our current result. LSTM is a baseline model. We can see after adding the CRF layer, the performance becomes better. And the CNN seems more effective than RN. Variational sequence labelers performs better than the previous three models. After adding the CRF layer to the variational sequence labeler, the performance also improves. The previous models are trained with only label data. When adding the unlabeled data to train the VSL, we found the performance increase. For the last two experiments, we are still training the model. but we will put our final results to our final reports. Thank you.